Okay, so we're going to take a look at some more examples of implicit differentiation. We're going to work on number 2 next. So we have the curve y cosine of x equals x squared plus y squared. And we're going to find the equation of the tangent line at 0, 1. Okay, so here's our problem. We're going to use implicit differentiation here to calculate derivatives. So we're going to differentiate the left-hand side. As we go about this, notice that this is a product, so we're going to be using the product rule. On the left-hand side, we have y times the derivative of cosine x plus the derivative of y times cosine x. And this is going to be equal to, we're going to differentiate x squared, and we get 2x. And we're going to differentiate y squared, and we'll get 2y times its derivative y prime. All right, so let's just rewrite this a little bit. We have y times negative sine x plus y prime times cosine of x equals 2x plus 2y, y prime. I'm just going to highlight where we see what we're interested in. If we're looking for the formula dy dx in general, then it makes a lot of sense to do some algebra to solve this. But something we can also often do to simplify what we have to work with is to actually, if we're looking at for a slope at a particular point, for example, here, where x equals 0 and y equals 1, we could also evaluate both sides of this equation at x equals 0 and y equals 1. This will make the expressions we have to work with easier to handle. So we have 1 times negative sine of 0 plus y prime times cosine of 0 equals 2 times 0 plus 2 times 1 times y prime. Okay. All right, and if we recall, sine of 0 is just 0, and cosine of 0 is 1. So our first term just goes away because it's 1 times 0. 2 times 0 goes away. And we're left with y prime equals 2y prime. So solving for y prime, we have that 0 equals y prime. And so now if we want to build our tangent line at 0, 1, we have y minus the y value is equal to 0 times x minus the x value, which was 0. And this term gives us just 0. So y equals 1. And we can double check our work by looking at Desmos. So I'm going to pause and pull that up. Okay, so this produces this funny egg-shaped graph. We have the point 0, 1, and what we found for our tangent line was y equals 1. Taking a look at our graph, we see this is absolutely correct. Awesome. Let's take a look at another example.